Hey there, this is MathCamp321, and in this video, Integration by Substitution, I plan to give you two examples of substitution and definite integrals. Those are integrals in which we have an upper and lower limit of integration. We can tell this easily by the inclusion of those numbers at the top and bottom of the integral symbol. So let me show you how to do this. We're going to start by allowing u to be x squared plus 1. Differentiating both sides with respect to x, I end up getting du dx equals 2x. Cross multiplying, we get du equals 2x dx. We notice that our integrand does not have a 2 floating around, so I'll divide out that 2 and rewrite the following as 1/2 du equals x dx. And I'll take all of these facts and I'll place them in a box for organizational purposes. Now I'm going to take the problem, I'm going to rewrite it so that that x, which is in the front, is more toward the back. And let's just observe that our integrand ends with x dx, and so does the fact in the bottom of our box here, x dx. Now let's rewrite our problem exclusively in the variable of u. So instead of x squared plus 1 cubed, I'm going to say u cubed, and instead of x dx, I'm going to say 1/2 du. Now, what I'm about to show you is the major difference between definite integrals and indefinite integrals with u substitution. These limits of integration right here, this 0 at the bottom and the 1 at the top, those occur only in the case where the variable is x. We've rewritten the problem in terms of u, so those limits are going to need to change. To figure out the new limits, you're going to plug these limits, which are in terms of x, into this equation here. So for our bottom limit of integration, we're going to allow x to be 0. And if we allow x to be 0, we get u is equal to 0 squared plus 1, which is 1. So that's going to go here. So let's notice that the lower limit has changed from a 0 to a 1. Now the upper limit is going to be found by replacing x with 1. So we're going to get u equals 1 squared plus 1, or 2. So the upper limit has changed from a 1 and is now a 2. And now we can just proceed as normal. I'm going to write 1/2. I'm going to leave some space, raise the power from 3 to 4, multiply by the reciprocal, which would be 1/4. Draw the bar. On the bottom of the bar would be a 1, and on the top of the bar would be 2. Notice also that we do not need a plus c in this problem because it's not an indefinite integral, it's a definite integral. Now cleaning this up, we have 1/8 u to the 4th, and this needs to be evaluated by first substituting in the 2, and then substituting in the 1, and finding the difference. Now 2 to the 4th is 16, and 1/8 of 16 is 2. 1 to the 4th is just 1, so 1/8 times 1 is 1/8. 2 minus 1/8 would be 1 7/8, or 15/8. So this 15/8 is the evaluation of this definite integral, and it also represents the area under this curve, if you were to graph it, starting at x equals 0 and ending at x equals 1. So the important thing to remember for integration by substitution for definite integrals is you need to change your upper and lower limits of integration in this first substitution step. Let's take a look at one more example to solidify some of these concepts. Here we have another example of integration by substitution involving a definite integral. I'm going to start by allowing u to be 2x minus 1. I'll differentiate both sides with respect to x. I'll cross multiply, and I'll divide both sides by 2. For organizational purposes, I'll take all these results and place them in a box. And I also observe that my initial integrand contains this extra x. So this is a slightly more challenging situation. The next step will be to take my first expression in the box and rewrite x in terms of u. So I'll start by saying 2x equals u plus 1, which means that x equals u plus 1 over 2. Now I'm also going to need to change my upper and lower limits of integration. So right now my upper limit is 5, and I'm going to plug that 5 in here in order to figure out what my new upper limit's going to be. So we've got u equals 2 times 5 minus 1, which is 9. And my lower limit can be found by plugging in 1 into this x here. So it's going to be 2 times 1 minus 1, which is going to be 1. And that's interesting. Sometimes when you do the substitution of your limits of integration, you end up getting the same thing that you started with. That happens from time to time, so don't be alarmed if it does. So now we're ready to rewrite our problem exclusively in terms of u. So we have an x on the top, and that x is really u plus 1 over 2. We've got 1 over root 2x minus 1, which is really 1 over root u, or 1 over u to the 1/2. And then it ends with dx, which is really 1/2 du. And our limits have changed from 1 to 9. Notice, this is our new lower limit, and this is our new upper limit. Now I'm going to take this 2, and I'm going to pull it outside of the integral, making it 1/4. And let's condense our fractions here and say u plus 1 over u to the 1/2. And now let's do a division technique to simplify a little bit further. Many over 1. U divided by u to the 1/2 is u to the 1/2. And then 1 over u to the 1/2 is u to the negative 1/2. Now we'll take the antiderivative. I'll leave some space. The power of 1/2 becomes 3/2. We'll multiply by the reciprocal 2/3. I'll leave some space. The power of negative 1/2 becomes 1/2, the reciprocal of which is 2. And then we've got our bar here. We're going to go from 1 to 9. I'll distribute the 1/4 through. This gives us 2/12 or 1/6. 1/6 u to the 3/2 plus 1/4 times 2u to the 1/2 will be 1/2 u to the 1/2. Because this is a multi-termed expression, I'll put parentheses around it. I'll put my bar. I'll first substitute in 9 for u, then 1 for u, and then find the difference. Now the square root of 9 is 3. 3 cubed is 27. So we have 27/6, which is 9/2, plus the square root of 9 is 3, so this is 3/2, minus 1/6 plus 1/2. I'm really running out of space here, huh? So let's come over here where there's a little bit more room. 9/2 and 3/2 is 12/2 or 6. And then we've got to do 1/6 minus 1/2. Let's see. So the common denominator would be a 6. So this ends up being 1/6 plus 3/6, which is 6 minus 4/6, which is 2/3. So this is going to be 5 1/3, or 16/3. Wow, that was a really involved problem. There was a lot of things we had to do there. We had an extra variable in the u substitution. We had to change the limits of integration. We had all this arithmetic to do. There was definitely a lot to it. So I hope with these two examples you have a better idea of how to do u substitution involving a definite integral.